Good morning all, I'm Joyeta Moietree and today is basically a favorite special class because I'm going to present on one of my most favorite subject, which is physics. And not only that, from physics I'm going to present on one of my most favorite chapter from physics, which is thermal physics. And yes, thermal physics is a very big section of chapters. So what I have done is I have divided thermal physics into different chapters, and today the chapter I am going to speak about is simple kinetic theory of matter. And then again, this chapter is pretty big, so I will be dividing this chapter into two parts, and today is the first part of this chapter. So before I actually start speaking about this chapter, I will request all of you to look at these small papers and see what is written here. Let me read it out for you. The first one says density equals to mass by volume. Second one says pressure equals to force by area. And the third one says pressure equals to H rho g. So the reason I have asked to read these things is to make sure that you guys are well known with these three equations and you have at least the basic knowledge about these things, because if you don't have the basic knowledge about these three equations, it will be difficult for you to catch up from my presentation on this chapter. Alright, so since we are done with reviewing the basics, let's get started with this chapter. So this is something we do in literature, that is we analyze the title. So let's do it for the first time in physics, that is literature in physics. So let's analyze the title. So what do we have here? We have our first key term, which is kinetic theory. So what does kinetic theory remind us? It just brings an idea, I guess, of some particles, or particles called atoms, or groups of particles called molecules. And kinetic theory, yes, so probably those particles or molecules, they might be moving, they might be in motion, so they will be having kinetic energy. Alright, that is some idea we can predict about this chapter, that it might be about molecules which are moving and they have kinetic energy. So let's look at our second key term. What do we have? Matter. Yes. So we can understand that yes, these particles or molecules, they will be of matter, particles of matter. So matter, basically, when we speak about matter, two things, at least for me, it just comes in my head. That is, number one, the three states of matter, which is solid, liquids and gas. And number two, it is super boring. We have been studying matter from grade 2 or 3, I guess. I'm not sure about it. But yes, it was pretty boring for me to study the same things again and again. But studying this chapter, it felt very cool to me, because in this chapter we are not going to study what solid, liquids and gases are, or just the list of their properties, but actually understand how did they get their properties. I think that was the part of our understanding that was a little vague. Our understanding was not clear in that part. So let's solve it and let's get started. So I am going to start with a very boring part, that is matter over here is three types, that is solid, liquid and gas. We all know it. This is very simple. So basically let's get started with the properties of solids, liquids and gas. I know all of you have the idea about the properties of solids, liquids and gas, but the reason I have asked you to actually read it out, or I'm introducing this to you, is because so that you can think about solids, liquids and gas. So let's get started. So in solids properties, the first property is they have a fixed shape and fixed volume. That is pretty much like a common sense. Next one, solids are hard and rigid. So how many of us know the difference between hard and rigid? Do they mean the same? Is hard the same thing as rigid? Definitely not, because if they were the same, then I wouldn't be mentioning the two. Like, two of them won't be written together. because if two things mean the same, one is definitely unnecessary. So who knows the difference between hard and rigid? Well, I can see a lot of people trying to answer. Alright, let me answer on behalf of you. Hard basically means that it is difficult to break, and rigid means that the molecules, they are in a fixed position. So when we say solids are hard, it means solids are difficult to break. But when we say solids are rigid, it means that the molecules in solid, they are in a fixed position. So I hope now the difference is very clear to all of us. Now let's see, among solids, liquids and gas, solids, they have the highest density. And lastly, solids, they are incompressible. Now let's move to liquids. What do we have? We have a fixed volume. Alright, so liquids, they have a fixed volume but not a fixed shape. Alright, liquids, they also have a high density and they are not compressible. And at last we have gas. So gas, they don't have a fixed shape or fixed volume. They have very low density and they are compressible. So yes, we are now very known with the properties of solids, liquids and gas. Basically, there are more properties of solids, liquids and gas, but I guess this was enough to take you in the zone so that you can think and feel about solids, liquids and gas. Oh dear, I think I'm the first person who is saying that you can feel about solids, liquids and gas. I know I'm super weird. Alright, so I think we do have a basic idea when we hear the term, as we know the term molecules and particles, that the matter, they are actually made up of these molecules or particles, and these molecules and particles, they are in continuous and random motion. And we know that these solids, liquids and gas, they also have these molecules. They have certain arrangement of molecules and they also have certain movement of molecules. But do we know how did solids, liquids and gas, they actually got their properties? These properties that they have. Well, some of you might say that, oh yes, they get these properties because of the arrangement of the molecules, because of the movement of the molecules. But my question is, why will certain arrangement of molecule lead to that respective property, or certain pattern of movement lead to that individual property? Let me make the question more clear to you. That is, suppose we know that the molecules in solid, they are in a fixed position and they cannot move freely, but they can only vibrate about their fixed position. That is a basic knowledge we all have about solids. But how is that related to solids having a fixed shape and fixed volume, solids being very dense or hard and rigid or this, and the same thing for liquids and gas? How is it related? That is basically our target that I am going to talk about today mostly. So let's get started. And I think that is the most fun thing of this chapter, which is not boring to me but super interesting. So, as we all know that the molecules in solid, they are fixed in a position. So they are fixed together in a regular pattern and they are very tightly packed, maintaining minimum space among the molecules. So that gives us an idea that the molecule, like they are arranged in so tightly so that volume, that must be small. And again, going back to basics, where density equals to mass by volume, if the volume is small, then we can predict why the density is high, because their relationship is inversely proportional. So now we can actually learn that why do solids, they have a high density? Because they are so tightly packed and their volume is why small, and hence density is super high. So next doubt is then, why do they have a fixed shape and fixed volume? That is also pretty easy. That is, we know the solid molecules, they cannot move freely but only vibrate about a fixed position. Again, why is that? That is pretty easy. You all can answer, I'm pretty sure. That is, solids, molecules, they have a very strong intermolecular bond between them, and because they have a strong intermolecular bond, That is why those molecules, they cannot move freely but vibrate about their fixed position. And that is why the solids, they basically have a fixed shape and fixed volume. And in fact, due to their strong intermolecular bond, solids are incompressible. And I guess now we understand that why solids are hard and rigid. It's all related to these things. Now let's move to liquids. So in liquids, we know that molecules in liquid, they are clustered together but also far apart. That is basically an interesting arrangement, that they are clustered together and also far apart at the same time. Clustered together and far apart. Alright, so because they are clustered together, their volume is also small. Maybe not as small as solids, but they are small, and hence their density is high. Again, maybe not as high as solids, but they are high. But since they are clustered together but also far apart, which shows that they have very weak intermolecular bond, that is why you can observe that liquids, they always tend to form droplets. That is the reason. And since they have very weak intermolecular bond between the molecules, they can move very freely. So that is why liquids, they don't have a fixed shape. But then why do they have a fixed volume? Why? Alright, this is because even though they have very weak intermolecular bond, but there is still an intermolecular bond. And because of this intermolecular bond, they have a fixed volume. Now let's move to the final one, which is gas. So gas, we know it's pretty easy that the molecules, they are very far apart, and basically they have the maximum space among the molecules, and that is why their volume is very large and hence their density is very low. So we know why density is low. And we also know about gas that the molecules of gas, they can move freely in random direction with high speed. Hence they don't have a fixed shape or fixed volume, and also they have negligible force of attraction between the molecules, and due to this gas, they are basically compressible. So I hope now it was clear to all of you, because this part of our understanding was not clear, that why do solids and liquids and gas, they get their properties just because of certain arrangement or movement of molecules. But I think it was clear to you, and I was able to build interest in you regarding this topic. Now I will solve another very interesting part of our understanding, which was unsolved again to us. So how many of you have heard the term called thermal expansion? Basically expansion. I did. So what did we learn about thermal expansion or expansion? Basically we learned the fact that when temperature increases, volume increases. Basically that is the thing. By volume increases, we means that things expand. Like matter, if we heat the matter expands. That is it. But we did not really know why it happens until we studied this chapter or this topic. And this is also, I think, very interesting, because according to the law of conservation of energy, what do we know? We know that energy can never be created or be destroyed. It can only be transformed from one form to the other. So what does it mean by increasing temperature? When we increase the temperature, in other words, heat energy is provided, or thermal energy is provided to the matter. So the molecules in matter, they basically gain this thermal energy in form of kinetic energy. And what is the form of kinetic energy? Let's see if you can remember. Oh, a lot of us can. I can see that. So the formula of kinetic energy is half mv square, where v stands for velocity, or you can say speed. So when they gain more kinetic energy, the molecules, they start moving with higher speed, and since they start moving with higher speed, the molecules, they try to move further apart from each other. And since they try to move further apart from each other, and when the mass of the matter stays constant and the atmospheric pressure stays constant, When these molecules, they try to move further apart from each other, it causes the volume of the matter to increase. And when the volume increases due to a rise in temperature, that is what we term as that expansion, that matters expand when temperature increases. Yes, and I found this entire explanation pretty cool because I did not know about it, so it was pretty interesting to me. And not only that, we have heard another fact about thermal expansion, that is, gases expand more than liquids and liquids expand more than solids. Again, why is that? Do we know why gas expands more than liquid or liquids expand more than solids? Anyone? Anyone of us? Any idea? All right, I can see a lot of doubtful faces, so let me answer it. That is, basically, what do we know about gas molecules from, again, our basic ideas? That is, the molecules in gas, they are very far apart from each other and they are moving in random direction with high speed. So what does this say about the molecules? The molecules, they already have high kinetic energy. So if we follow this logic, obviously gas molecules, they have higher kinetic energy than liquid molecules, and liquid molecules also, since they are moving, they have more kinetic energy than solid molecules. And so due to an increase in temperature, we know that the molecules, they gain more kinetic energy. So since gas already had more kinetic energy from before and they were already far apart from each other, when they gain more kinetic energy, the molecules, they are moving more further away from each other, and that is why we say that gases expand more than liquids, because the average kinetic energy or the total kinetic energy of gas molecules will definitely be more than liquids. So that's why gas molecules, they expand more than liquids, and the same logic applies why liquid molecules expands more than solids. So yes, with that we are actually done with knowing some of the basics about this chapter, about solids, liquids and gas, about molecules of matter. And if you think this is the entire of this chapter, you are pretty wrong, because this is the basic knowledge that we all need to study the most interesting and exciting part of kinetic theory of matter. And yes, I can give you a clue that in the next part of this chapter, I will be speaking not about the 3 states of matter, but only one of the state of matter, and you can actually guess about it, which state of matter will I speak about in the next video. And I hope it was interesting to you, because this was one of the most favorite chapter to me, and it is still now, because I found it super cool. So I hope I was able to build interest in you as well. And yes, thanks to all of you who have watched my video till the end. And yes, stay home, stay safe, and most importantly, stay cool. Thank you so much.